Hello everyone, this is OM Prakash and dear student. Today we are going to start the syllabus of mathematics of standard 8, and the first chapter is rational numbers. This means that this is the first part. You have already been introduced by this topic, the rational number, in previous session also. We will see from the beginning basic topics. First topic is natural numbers. Dear students, natural number. What is that natural number? That all counting numbers are called natural numbers. Okay? And it is represented by capital N. And those set of numbers are 1, 2, 3, 4, 5, 6, 7 and so on. Okay? Coming to the next topic, which is whole numbers. Students, what is whole numbers? All counting numbers including 0 are known as whole numbers. And this means it is represented by capital W and set of numbers are 0, 1, 2, 3, 4, 5, 6 and so on. Our next topic is integers. What is an integers? That all counting numbers, their negatives and 0 are known as integers, and it is represented by capital Z. This means, and those set of numbers are 0, 1, 2, 3, 4 and so on, and the negative side also -1, -2, -3 and so on. Okay? Distance. Now our next topic is rational numbers, which is the name of our chapter also. Rational numbers. What is that? A number in the form of P by Q, where P and Q are integers and Q is not equal to 0. This is known as rational numbers. Is known as rational numbers. Examples will be 1 upon 2, 3 upon 4, 0 upon 5, -4 upon 6, etc. This means rational number we have divided into 3 parts: positive rational number, negative rational numbers and zero rational numbers. Okay? Coming to the next topic, properties of rational numbers. Some properties are there, and we are going to start with closure properties. Closure properties. For addition, dear students, when two rational numbers we will add, the result you will find that again it is rational number only. In case of subtraction also, you will see when two rational numbers you will subtract, you will get again a rational number as a result. In multiplication also, it is shown here on board. In multiplication also, when you will multiply two rational numbers, the result will be again a rational number. So, rational numbers are closed under addition, subtraction and multiplication. It is clear here. It is shown. But for division, you will see example here: 3 upon 7 divided by 0 upon 5. Dear students, 3 upon 7 is also a rational number. 0 upon 5 is also a rational number. So, when we do the division process, what is there? Not defined, because 5 upon 0 is not defined. 5 upon 0 is not defined. So, rational numbers are not closed under division. Rational numbers are not closed under division, dear students. Our new topic is commutative property. And again we will do the same process for addition, for subtraction, for multiplication and for division. We will check that whether it is satisfying or not. So in case of addition, if A and B are any two rational numbers, then A plus B will be equal to B plus A. We will see with one example that whether this relation is satisfying or not. Okay. Dear students, now we will see the example of commutative property of addition. Here it is written on the board. 3 upon 4 plus 1 upon 2 is equal to 1 upon 2 plus 3 upon 4 or not. We will see that. So LHS, we will take LCM of 4 and 2, which is 4, and when we will calculate that, we will get 5 upon 4 as a result of LHS. Now we will see the RHS. LCM of 2 and 4 is 4, and when we will calculate, we will get 5 upon 4. This means LHS and RHS both are same. So in this case, we will say that addition is commutative. Addition is commutative for rational numbers. Now we will check for subtraction, difference. That yes, for subtraction we will check now that 3 upon 2 minus 1 upon 2 is equal to 1 upon 2 minus 3 upon 2 or not. Means A minus B is equal to B minus A or not. So we will check that. So LHS we obtain 1 upon 6 and RHS minus 1 upon 6. Dear students, these are not same. So we will say that subtraction is not commutative for rational numbers. It is written also, subtraction is not commutative for rational numbers, dear student. Now for multiplication we will check. If A and B are any two irrational numbers, then A into B is equal to B into A. We will see with one example also, and when you will multiply that A into B is equal to B into A, then you will see that LHS and RHS both are same. Now this means in the case of division, you can see here it is not same. When we have calculated with rational numbers, you will find that LHS and RHS are not equal. So in this case, we will say that division is not associative for rational numbers. Division is not associative, actually it is commutative. Dear students, now we will see division for commutative property. LHS and RHS, it is written here. When we will calculate distance A divided by B, you will get minus 9 upon 14 with some examples. And RHS B divided by A minus 14 upon 9. This means these are not same, LHS and RHS. So we can say that division is not commutative for rational numbers. So this means let's come to the next new topic, which is associative property. This means in this addition you will see that if A, B and C are any three integers, then A plus bracket start B plus C bracket close is equal to bracket start A plus B bracket close plus C is written here. And in case of multiplication, if A, B and C are any three integers, then A into bracket start B into C, that is equal to bracket start A into B bracket close into C. So this is what? Multiplication for associativity. Okay. Now subtraction and division. This means subtraction is not associative for rational numbers, and division is also not associative for rational numbers. You can check through some examples. When you will check you will take three rational numbers. Yes, when you will take three rational numbers, then with these properties you will check, you will find that which are possible, which are not possible. Okay, students, in this part up to here only. Again we will meet in the next part. Okay, thank you.
Please like, share and subscribe. Thank you.